Hello, everyone. I'm Junko Ichino from Tokyo City University. I will give a presentation on how gaze visualization facilitates initiation of informal communication in 3D virtual spaces. Background: a serendipity, which is considered essential for discovering clues to solve problems and create innovations, often arises from informal communication. Opportunities for informal communication have decreased as people spend more time in digital space, where informal communication is less likely to occur. This can lead to closed communities in which biases can be reinforced through a lack of diverse opinions. Therefore, future communication media in digital spaces should develop a mechanism to induce informal communication. Motivation: in a physical space, prior to the initiation of informal communication, eye gaze plays an important role among social cues. Conventional communication media in the digital space, such as text chat and video conferencing, offer few social cues communicated. In contrast, a 3D virtual space offers more social cues, making this a promising new communication medium. However, research on how to present social cues in 3D virtual space is insufficient. Here, our goal is to investigate how the visualization of gaze cues in a 3D virtual space can facilitate the initiation of informal communication. We address two research questions. The first question is, does visualization of gaze cues facilitate initiation of informal communication? The second question is, do different visualization styles impact the behaviors and experiences of users? The two figures here represent process models for initiating informal communication. The left figure is the case triggered by one-sided gaze, that is one user looking at the other. The right figure is the case triggered by joint gaze, that is two people looking at the same reference object. We consider these two types of gaze behavior as a target for visualization. We considered the requirements for designing gaze cues to facilitate the initiation of informal communication from the perspectives of perception, cognition, and affect. As for perception, a cue receiver can perceive the cue from a cue sender, who is likely to be outside the receiver's field of view without missing it. As for cognition, a cue receiver can identify the location of a cue sender, who is likely to be outside the receiver's field of view. As for affect, cues attract the interest of a cue receiver who is likely to be engaged in a task. We selected 3 visualization styles with different visual representations, arranged them to satisfy the design requirements, and designed and implemented them. Arrow points in the direction of the cue sender. Bubble flows from the direction of the cue sender. Manavatar is a miniature avatar of the cue sender and moves to the location of the sender. It was difficult for Arrow to satisfy effect requirements, but we included it in our evaluation because it can be a baseline for a visualized gaze cue. Here are videos of the 3 visualization styles for one-sided gaze. First one is Arrow for one-sided gaze. Next, Bubble for one-sided gaze. Next, Manavatar for one-sided gaze. Next are videos of the 3 visualization styles for joint gaze. The first one is Arrow for joint gaze. Next, Bubble for joint gaze. The last one is Manavatar for joint gaze. We designed a study to answer our research questions at the beginning of this presentation. We employed a 1x4 design with different gaze cue visualization styles, no gaze cue visualization, control, and 3 types of gaze cue visualization, arrow, bubble, and manavatar. We used a between subjects design. We employed 3 confederates to simulate a situation where informal communication was initiated. The participants were not informed of the study purpose. A total of 96 participants were recruited from the public. They were divided into 4 groups to equally represent gender and age across the study conditions. During the study, in virtual space, the 4 members, including 1 participant and 3 confederates, were in the same room. In the physical space, only the participant was in a different room. The study comprised 3 sessions, a warm-up session, task session, and free session. During the warm-up session, each member was free to browse the readings at hand or the wall posts. We designed this session for a context in which a user without a task in progress is approached by others. During the task session, each member performed 3 tasks in the assigned area. We designed this session for a context in which a user with a definite task in progress is approached by others. During the free session, the members were free to spend their time as they wished. During the warm-up and task sessions, each confederate executed 1 approach mission 6 times in total. The next slide explains this approach mission. In one approach mission, the confederate will send a maximum of 3 gaze cues to the participant, according to the action guidelines, as shown in this flowchart. The next slide shows any reaction. We defined the participant's reaction as shown in this table with level 1 or higher as any reaction. Level 0 is no reaction, level 1 is glancing reaction, level 2 is nonverbal reaction, and level 3 is verbal reaction. Gaze type and the position and timing of gazing were predetermined. Information such as future positions and timing of moves was provided to the confederates by voice or vibration during the mission. To avoid making participants feel unnatural, the 2 off-mission confederates interacted in a similar way to that between participants and the confederate. The confederates performed their missions in the same manner under the control condition. The next will discuss the measures we employed. First, we employed 4 objective measures of behavior. The first is the approach mission success rate, which is the ratio of the total number of any reaction times by the participants to the first or second gaze cue from the confederates, to the total number of the approach mission by the confederates in all the studies. The second is the verbal reaction rate, which is the ratio of the total number of verbal reactions by participants to the total number of gaze cues sent by the confederates to the participants during the approach mission in all the studies. The nonverbal reaction rate and the glancing reaction rate were also obtained in the same way as for the verbal reaction rate. We also examined the participants' experiences using Likert scales and open-ended statements from the questionnaire. The scale comprised 4 subscales: perception, cognition, positive affect, and negative affect, based on the design requirements of the gaze cue, which were used for both one-sided gaze and joint gaze. Now, I'd like to move on to results. First, here are the objective results for behavior. These graphs show the 4 rates for one-sided gaze. From left to right, approach mission success rate, verbal reaction rate, nonverbal reaction rate, and glancing reaction rate. As you can see, the participants reacted more to all visualized one-sided gaze, particularly bubble, than to non-visualized one-sided. The participants also reacted well verbally and nonverbally to bubble, and nonverbally to manavatar. The next slide shows the results of joint gaze. As you can see, the participants reacted more to all visualized joint gaze than to non-visualized joint gaze. There were no noticeable differences among the visualization conditions. Next, here are the subjective results for experience. These graphs show Likert scales ratings for one-sided gaze. From left to right are the results for perception, cognition, positive affect, and negative affect subscales. As you can see, the participants rated all visualized one-sided gaze as easier to perceive and identify than non-visualized one-sided gaze. The participants had positive affect for bubble and negative affect for manavatar, although not significantly different. The next slide shows the results of joint gaze. Similar to one-sided gaze, the participants rated all visualized joint gaze as easy to perceive and identify. The participants had positive affect for bubble and negative affect for manavatar, although not significantly different. This table shows the open-ended statements of the participants by gaze type and visualization style. As you can see, bubble had the most positive comments. In particular, joint gaze with bubble had comments on a sense of togetherness with the other person. Regarding one-sided gaze with manavatar, the participants' evaluations were split. Joint gaze with manavatar had comments on the ease of initiating communication. From now on, I will discuss the results. This table summarizes the answers to our research questions. The answers to the question 1 were yes for both one-sided and joint gaze. The answer to the question 2 was yes for one-sided gaze. Overall, bubble, manavatar, and arrow received positive feedback in that order, although the only statistically significant difference among the 3 visualization styles was in the verbal reaction rates. The answer to the question 2 was no for joint gaze. Next, I would like to compare the availability of one-sided and joint gaze. The left graph shows the approach mission success rate as shown before, which indicates its use as a cue receiver. As you can see, overall, the visualized joint gaze is higher than the visualized one-sided gaze. The right graph shows the new data, the participant's frequency of sending cues, which indicates its use as a cue sender. The visualized joint gaze is over 3 times higher than the visualized one-sided gaze. According to these results, the joint gaze cue is more likely to be accepted by users than one-sided gaze cue. The joint gaze cue may motivate users to interact with others, as it informs that they are interested in the same target. This slide will address implications for design of gaze cue visualization. We reviewed the 3 visualization styles from 3 perspectives related to visual representation: bubble, manavatar, arrow. This is the order of receiving positive feedback. Bubble and manavatar, whose visual representation of cues was substantive, satisfy not only perception and cognition, but also affect design requirements. A bubble, which received the most positive feedback overall, had the visual linkage between the cue and its sender, namely wired. As a result, the interaction is less likely to be terminated in midway. Bubble also had a subtle visual representation of the cue. This probably led to wider receiver acceptance. Finally, we discuss implications for study design for evaluating reactions to social cues. We designed the study with minor deceptions, as shown here, to observe participants' natural reactions to social cues. First, we did not inform the participants of the detailed purpose of the study. Second, we pretended to the participants that it was time out of the study, such as warm-up time. Third, we used confederates to set up casual encounters. Fourth, we presented interactions similar to those between the participant and the confederate as camouflage by the remaining confederates. The methodology of this study can be used as a template for evaluating reactions to social cues, including gaze cues, in studies on informal communication and social VR. Thank you for listening to our presentation.